So next up we have, next up we have Noah Franz, who's going to be telling us about OTTER. It'll go to red when questions. It's okay, so.
Thank you for the introduction. Yeah, so I will be telling you all about the open multi-wavelength transient event repository, which is in collaboration with a bunch of other people, many of whom are in this room. And I want to begin by emphasizing something that I think has been a common theme of this conference so far, and that is that exploring the multi-wavelength properties of transient events is essential for fully characterizing them and extracting physical constraints of the system. As an example, I'm showing the TDE Assassin 15Y and a plot from Aprajita Hajla's 2025 paper, where she presented about 8 years of data spanning from the radio to the X-rays on this event. And by doing this, by exploring when different wavelengths were flaring and things like that, she was able to extract the physical origin of the different emission components. But as we've seen, this is not just applicable to TDEs, but also supernova, gamma ray bursts, and FBOTs like 24 WPP. But the problem is that these multi-wavelength data sets are spread all over the place. They're in one-off single object papers. They're in outdated public catalogs like the Open Supernova Catalog or Open Astronomy catalogs. And they're in population study papers. And to further complicate the situation, there's actually overlap between all of these things, right? So you can imagine a population study paper that includes a lot of data from a bunch of different one-off single object papers, but also presents new data. And so when compiling a catalog, you need to deduplicate all of this data and make sure you're not using the same observation twice. And so this is what OTTER is. Hopefully, we are hoping to compile all of the transient data, deduplicate it, and put it in a central repository for everyone to use. And this includes both software infrastructure and, of course, the catalog itself. And it's currently focused on transient event photometry and metadata. It's built on a standard but also flexible document database schema, JSON-like schema that supports multi-wavelength data sets inherently. And there's currently 3 software components: a scalable backend database, an API for bulk access to the light curves for you all to use in your research, and a web application for interfacing with the data, getting a quick view of it, things like that. And so this diagram shows all 3 of those components. So in the top left, we have the database. The database, unlike a relational SQL database, it's basically a storage of a bunch of JSON documents, but in a really fast searchable way, making it scalable for things like Rubin and Roman. And currently, we have 2 different collections of documents in this database. We have the pristine transients collection, which is the user-facing one. That's what you all see. And then we also have a staging ground for new data sets to make sure they look correct before we make them user-facing. This is all stored at SciServer, hosted at SciServer, which is at Johns Hopkins. In the top right, we have the API. What's nice is OrangoDB, which is the database management system we use for OTTER. It has a built-in RESTful API. This is fantastic, but it requires learning something called Orango query language. It's this kind of abstract language to access all of the data. So to make it easier to access the data, we've wrapped this RESTful API into a Python API for anyone to be able to use quickly and easily. And then finally, we have the web application. This has a bunch of pages like the homepage, search pages, and individual transient pages where you can view light curves, SEDs, things like that. And so as a user, we'd imagine that you start here. And one thing you may want to do is query the database. When you do this, it goes through the API proxy and to our database. This lets us make sure we're not being DDoSed, as was mentioned earlier. But another thing that we hope you want to do is also contribute to this data set. And so through the website, you can also upload data after publishing, allowing the community to easily access it and use it for their research. After uploading, your data goes into this staging ground, this vetting collection, which is then where we currently have an admin come in. And so what this admin does is they go to a vetting page on our website, and they're able to view the new data sets and as has always happened, approve them, but in maybe rare cases, deny them or reach out to the authors to figure out why it doesn't look proper or something like that. And so we started OTTER as a TDE catalog, a title disruption event catalog, where, as I mentioned earlier, we have a scope limited to metadata and photometry. And a lot of the infrastructure is built to support optically discovered transients like supernova, TDEs, and FBOTs. And importantly, the TDE catalog should be complete up through about 2024. We've gathered a lot of the multi-wavelength photometry on these events, which I'm showing on the right here, where all the individual points are different photometry points we have, and all of the contours are the really, really dense regions where we just kind of stack them all together. One thing I think is really cool about this is you can clearly see the two different populations of tidal disruption events in the radio, where you have the jetted TDEs in the top and the Newtonian or non-relativistic TDEs in the bottom. But over the past 2 weeks, we have also incorporated all of the Open Supernova catalog data into OTTER. And so this is now what the breakdown of all of the transient classifications in OTTER looks like. So there's a good amount of unclassified things. These come from TNS. We incorporated everything in the Open Supernova catalog up until 2019. And that included a lot of just like AT named things. But there's also about 20,000 type 1A or supernova and about a few hundred, about 240 tidal disruption events, ambiguous nuclear transients, AGN, things like that. And so all of this data should now be easily accessible for everyone to use, once again, I guess. And this is showing all of the photometry that we now have, where it's a histogram, note the logarithmic y-axis, showing the photometry points per like wavelength bin or frequency bin, depending on which way you think. And as you can see, a significant portion of the data is in the UV optical infrared. This is probably not surprising since all sky surveys are in the optical. But then we also have a good amount of X-ray and radio data. And in the top right of this plot, I'm showing a pie chart where like 11% of our photometry is for tidal disruption events, about 68% for supernova, and then the rest for other events that we have. And so I don't think I have time to give you all a live demo, unfortunately, but this is what our web interface looks like. So on the left, we have the homepage where you can search just by name or do a cone search, things like that. Both of those are indexed in our database and are very fast. On the right side, once you do a search, say on the homepage, you get a table of the results. You can click on them and it'll take you to an individual transient page where you can view all of the metadata properties. This is like coordinates, redshifts, things like that. The same types of things you would find on TNS or WISE-Rep. But something different that I'd like to highlight, and maybe I picked a bad example here since 24 TVD is unambiguously classified as a TDE, but for other transients, they may have a more ambiguous classification, right? So a tidal disruption event could also be classified as an AGN flare by some people, or a superluminous supernova by others. And so we store all of those different classifications with different flags to allow users to search based on what they believe is like the true classification. On these individual transient pages, we also have things like photometry plots. This is showing the 2024 TVD radio light curve. And then you could switch that to like UV optical infrared light curve at the bottom there. And then below that, I'm not showing it, but you can also see the SED and things like that. And so I guess in summary, I hope everyone in this room agrees that consolidating a multi-wavelength data set is a powerful tool for the community. And as the number of events increases, especially over the next decade with Roman and Rubin, I think this is going to become a harder and harder problem to continue to maintain. And so some questions I have for you all is, how can we encourage the community to assist in maintaining a consolidated data set like this? And related to that, how can we make contributing data easier? Does anyone have like feedback on this, things like that? And if you do, please open a GitHub issue, please get in contact with me, things like that. And so in the future, we hope to, as I said, continue maintaining this catalog as new transients are discovered. And we really encourage everyone to upload their data after publication to make it easily accessible for others. And we hope to make this as painless a process as possible. We really want to add additional transients. So as I mentioned, we included everything in the Open Supernova catalog, but that was only updated until like 2019-ish. And so getting in all of the supernova in the past 7 years would be really, really cool. Including things like FBOTs would also be awesome. And if you're interested in contributing this data or have an idea of where I can find a lot of the data in one place, please get in contact with me. And of course, I think as many of the infrastructure developers here have said, we are always looking for additional developers and maintainers to help us continue to build this infrastructure and maintain the data set. So if you want to play around with the website, I encourage you all to do so. The link is right there, and I've provided QR codes for both of our papers. Thank you.
Okay, we have time for a couple of questions for Noah. I'll take Chess Proctive and start. And as I was saying in my talk yesterday, I think there's a discrepancy between us thinking about transients and variables, particularly when we're talking about nuclear transients. So are you open to things that may be slow transients in some people's books or variables in other people's books? You talked about AGN, and Charlotte was mentioning changing look AGN and that sort of thing. I mean, they are a viable class of a transient, and they can be slow and they can be fast, but that sort of thing. You're open to all sorts of categories, are you?
Yeah, absolutely. Yeah, we'd love contributions, especially like if we get a bunch of AGN light curves in there, is there a way we can distinguish TDEs from AGN if we have all of it in one place?
Yeah. Gautam?
Great talk, Noah. So how do you encourage people to upload data? In some sense, that's framing the question as how do they do you a favor, right? But that's not actually, I think, an approach. In some very real sense, you are providing a service to the entire community by aggregating this. And if you went a little bit further, let's say you could mint a DOI for an individual object and make that entity a citable thing that could be used in future papers, and have a simple thing like a JSON upload form that has all the data. I think people would rush to use your service because then their data and their papers get cited much more easily in the future by other people using the research. So I think this is exactly the right thing to do. And with like a little bit more stuff in it, people will happily use it. I mean, people used Open Supernova Catalog quite a lot. The challenge was just maintaining it for one person.
Yeah, I absolutely agree. I also think maybe something I should have emphasized more during my talk is all of the data we've aggregated here has an ADS bib code associated with it. And on our website, we have one of the pages, you can search an event name and it will give you a bibtec file of all of the citations, all the things you should be citing for that transient, making sure to give everyone credit who has touched the data on it. Yeah.
It's really good. But I like idea as well. Anya.
Okay, sorry if you mentioned this, but I'm wondering if there's a way to upload host galaxy data. And then I'm also wondering, I mean, oftentimes with host studies, we get better models in the future and then people repeat the study and get better results. Is there a way to amend current entries?
Yeah, so our current data schema has a host attribute, which allows us to store things like the host name, coordinates, reference, things like that, which then allows you to query external catalogs. A lot of those queries are built into our Python API too. So currently no, but this is another thing we want to extend in the future. We want to store like host photometry, like STSS photometry for all of these hosts. directly in the schema to make it easy, because as Charlotte said, as I'm sure you're going to say in the next talk, host galaxies are important. Yeah.
Can you tell us how you get data from pre-existing papers? And also, is it just photometry here and spectra and WISE-Rep, or is there any plans to do both?
So currently we encourage everyone to upload their spectra to WISE-Rep and their photometry here. We have as part of the Python API, we have a way to query WISE-Rep directly for additional spectra. And in the future, we hope to include spectra in this service as well. Sorry, what was your first question? Painfully going to the paper, taking the machine readable format, reading it into Python and reformatting it. It would be great if instead we had the community contributing their data after publication. One thing we've been thinking about is using, I think I mentioned, or I had this briefly on here, is just, can we give new transient papers to large language models, say, give me all of the photometry in this paper, send it to the author and say, please check this and upload it if it looks correct. Maybe that will take away a lot of the pressure or the time commitment necessary to do it. That's also a great idea, yeah.
You should talk to AAS journals.
Yeah.
Great, let's thank Noah again.